Hi, Cameron.
Hello.
How are you today?
How are you?
Good.
I'm good.
Okay. Why don't you tell me which of these you would like to go over?
Um, let's.
Have you had
Let's start.
trig before? Did we do trig?
Oh yeah, but I do need to refresh certain areas. Yeah.
Okay. Because I couldn't remember in your college algebra course whether they did trig or not.
Yeah, they did do trig.
Okay.
I found so far it's been pretty much the same as college algebra.
Yeah. Yeah, I don't see.
Very simple.
I haven't reviewed this whole document you sent me, but from what I'm looking at, it seems pretty basic trig. I don't see anything new.
Yeah.
Do you know how to convert degrees to radians?
Let's see. I'm trying to remember how do you do that.
Well, do you
Can
remember
you do that?
if you can remember the conversion factor, you can always figure out which way it goes.
Okay.
What is the conversion factor?
Um, that's what I don't remember actually.
Pi over 180 or 180 over pi, depending on which way you're going.
Okay.
What would we use to convert this one? Which one?
Would it be pi over 180?
Yeah, because the degrees need to disappear. Okay,
Hmm.
so if we multiply this by pi over 180, in other words, if you
Doesn't pi
forget
equal
which way,
180 as well?
what's that?
Doesn't pi equal 180 as well?
Yes, it does. And in fact, that's what this conversion factor says, is that you have pi radians for 180 degrees. So this converts it to 15/18 pi, which is what? If we divide 3 into both of those, we have 5/6 pi.
Hmm.
So there's what it is. But converting degrees to radians or radians to degrees, so what is this? If I have that many
So,
radians, and you
so
don't,
do 180 over pi?
yeah, you don't usually use the word radians there. But
Hmm.
exactly, you're going to multiply it by 180 over pi because we want the radians to disappear and we want it to end up in degrees. So in other words, the degrees always goes with the 180, the radians always goes with the pi, and that'll always show you how to do it. Pi's cancel. Equals 120. All right. You're supposed to omit these two?
Yeah, he wrote those in, so.
Okay. Is the pi over 6 the same as 13 pi over 6?
It's the same degrees, yeah.
Yeah. Well, it's also the same angle. Well, it's not the same angle,
But
but what they mean by coincide is if, whoops,
that should be, let me see, 180 divided by 6. A lot easier with a calculator.
if I have 30 degrees, well, if I go around 390 degrees, that gives me the same angle.
Yes.
So we're looking for multiples of 360 degrees or 2 pi. Now, if I subtract 2 pi from 13 pi over 6, I get pi over 6.
Yeah.
So that's what you always want to do with angles greater than 2 pi or 360 degrees is pull out as many 2 pi's as you can. In other words, if I
Oh,
had 25 pi over 6, well, I can pull out 4 pi. In other words, I can subtract 4 pi from that and end up with pi over 6. So that is the same trig functions as that. So you always want to pull out the greatest multiple of 2 pi to reduce the angle to an angle less than 360. About number 4. You know how to do 4?
We should go over 4.
Okay.
We've been over it in class, but I just don't remember how it goes.
Well, let's look at this as a geometry problem. It's not really a trig problem, it's a geometry problem.
Yeah.
What's the total circumference of this circle?
Oh, shoot. Is it pi or 2 pi? Pi r squared or 2 pi r? I need to look that up.
It's 2 pi r.
Okay.
Always remember that areas are going to have an r squared because you're going to have a meter squared.
Oh, yeah, that's good to remember.
Circumference is going to be a linear measurement because r is going to be meters. So you're going to end up with a linear measurement with circumference. You're going to end up with a square measurement with area. Also notice that area is pi r squared. Circumference is the first derivative of that, 2 pi r, using the power rule. Now, I don't know if you even know the power rule and first derivative, but it's a nice little way to remember circumference. Should always remember area, and then you need to remember them both, actually. If there's ever any two things you need to remember, it's the area and the circumference of a circle. So, what's the circumference of this circle?
2 pi r. So our radius is 5, so it's 2 pi 5 then.
So that's 10 pi.
Yeah.
That's the circumference of the circle. Now, what is the length of that arc?
Let's see. How can we find that?
What percentage of the circumference is that arc?
It is, let's see, 30%? No, 33%.
Well, this little one might be 33%, but they're asking about this arc here.
Oh, so that's 66% then.
2/3.
Yeah.
Right? Because it's the number of degrees, which is 240, divided by 360, which is 2/3. So what's the length of the arc? So if 10 pi is the entire circumference, and we've got 2/3 of it.
Oh, I see what they're saying. So 2/3 of 10 then. Oh. I'm not certain if I completely understand then.
Okay. The entire circumference is 10 pi.
Yeah.
This arc is 2/3 of the circumference.
So multiply them, do you?
Yeah. In other words, if it was half, I would take 5 pi. So whatever percentage of the full circumference that arc is, and it's always whatever this angle is divided by 360,
okay,
that's the length of that arc. Let me give you another one. Let me give you one. What's the length of this arc?
So our circumference is 10 pi again. And then we have 260 over 360. That's the area. Let's see if we can reduce that. That's 2/3 again, is it?
No, I just made those numbers up, so I don't know. That's 13/18.
So 2/18. And then we multiply that by 10 pi.
Yeah, and that's your answer. So 130 over 18 pi.
Yeah.
That would be the area of this part of the arc. And of course, this part here would be 10 pi minus this. Okay. Find the area of the sector.
And the sector is just the other thing then, the 65 degrees, am I right?
Okay. Yes.
Okay. So once again, we find the circumference, which is 40 pi.
No, we're looking for areas here, not lengths.
Oh, whoops. So we need pi 20 squared.
Okay, so 400 pi equals the area of the full circle.
Yeah. And the sector is 65 over 360.
And that's whatever that equals is your answer.
Yeah. Don't know if we can reduce that.
Yeah, that's not the important part. I'll leave that to you. Okay, if t equals 2 pi over 3, find the sine of t and the cosine of t.
So 180 over 3 is 60 degrees, so this is a 60-degree triangle.
Hold on. Hold on. Well, the angle is 2 pi over 3.
Oh, whoops.
So if we're going to convert that to degrees, that's fine. But let's make sure we do it right. What's the conversion factor?
That should actually be, pi should be 180, so that should be 360 over 3. Oh, conversion factor.
You don't change the pi. Multiply it by the conversion factor. It's either 180 over pi or pi over 180. Which is it?
180 over pi.
Okay. Now, what is the sine of 120 degrees without using your calculator? I presume you're not allowed to use calculator on this?
Yeah, we're not.
Good.
Okay, so this should be similar to a 60 degrees.
Yes. Let's look at our unit. Let's look at our unit circle. All students take calculus.
Yeah, I actually need to memorize the what you call it.
When you're in the second quadrant and you're given theta, what is the reference angle going to be?
So sine will always be positive.
Right, but we still need this delta, this reference angle. How do we get that? If this angle here is 120 degrees, in order to convert this angle to an equivalent first quadrant angle, which is the way I like to do all my trig functions, I like to turn anything greater than 90 degrees into the equivalent first quadrant angle. What's the relationship between these two?
60 degree.
Right, they're supplementary. So the formula is 180 minus theta. That's what you got to remember right there.
Yes.
In the second quadrant. In the third quadrant, what is the formula?
It should be, what would it be? It should
Theta minus 180, just the reverse.
Oh, yeah.
And in the fourth quadrant, that's kind of like the second quadrant, only we're now 360 minus theta. Okay. So by using these three things, depending on which quadrant you're in, you can always convert any angle to the equivalent first quadrant angle. In other words, this one converts to 60. Okay. So now we want the sine of 60, and we'll figure out whether to put a plus or minus sign on it after we do it. But what is the sine of 60?
Well, let's see. I'm trying to think. is the...
Okay, these triangles, you should have these memorized by now.
Yeah.
What's this side?
Mm,
What's opposite the 30? I always call these my unit special triangles because it's always 1.
oh.
What's this measurement here?
I
Opposite.
thought one of them was √3 on one of these. Maybe I'm wrong.
It's √3 on the bottom, and it's 2 there.
Okay, so I did know that one.
Okay, this is your 45, 45. What's opposite the 45?
Should it be 1?
This has to be 1. What is this?
Those. Or just 2?
Use the Pythagorean theorem.
1 squared plus 1 squared, so just 2?
Square root of that.
√2, yeah, that's what I have.
Remember that in the Pythagorean theorem, C is not equal to a squared plus b squared. C squared is equal to a squared plus b squared, which means C is equal to the square root of a squared plus b squared. And usually you're trying to figure out C, so don't forget that square root. So that makes it square root of 2. Okay? So these two triangles, memorize these.
Yeah.
They will allow you to calculate any trig function, and that's why I want you to memorize them, is because you can either memorize these or you can memorize this gigantic circle that they split into 16 different pieces.
Yeah, it's going to be...
Which one is easier?
Memorizing the triangles, and that's what I've been trying to do.
Okay. Not just the triangles. You have to memorize these two triangles, but you also have to memorize this diagram here.
Yeah.
And you don't need to memorize that part, but you need to memorize what you use to convert a second quadrant angle to a first quadrant angle. What you use to convert a third quadrant. In other words, what's the sine of 210 equal to?
Sine of 210?
Is the equivalent of the sine of what? What first quadrant angle?
That should be 30 degrees.
Right. In other words, you plug in 210 for theta. 210 minus 180 is 30.
Mm-hmm.
Okay, so let's go back and figure out what the sine of 60 degrees is, the absolute value of it.
Okay, so the sine of 60 degrees should be 1/2.
Opposite.
Oh, whoops, √3/2.
So, ka, toa. I used to say that if you had an infected toenail, you would soak a toa. Okay? So sine is opposite over hypotenuse. That's another thing you want to memorize, like your name. In other words, you don't want to memorize it, you want to learn it. You, for the rest of your life, you want to know that sine is opposite over hypotenuse. So what is sine of 60 degrees here?
So it's √3/2?
What's its plus or minus?
Just, that should be plus because it's sine.
Okay.
In this quadrant.
So that's the answer to that problem. The sine of 2 pi over 3 was square root of 3/2. Now how about the cosine of 120 degrees?
-1/2.
There you go. Because it's the same as the cosine of 60, which is 1/2, and because it's cosine, it's negative. I'm sorry, because it's in the second quadrant, it's negative.